remember that hexadecimal digits? We don't reverse the hexadecimal digits in Little Endian because 2 hexadecimal digits make up a single byte, and we reverse the bytes. So that's why we don't store like 80530C08. We store instead each pair of 2 digits starting from the right. So that address refers to the address of the start of our buffer that we actually wanted to copy into in the first place. The reason that's useful is because what if the attacker happened to, instead of having a string that was like just a harmless string of like their name or something, what if instead that string were like just some arbitrary code that did whatever they wanted it to do. So like they could, I can't think of any cool code. Okay. So it could be anything though, any disastrous code. If they wanted, they could just do something that segfaults, but that would be pointless. They usually do it to like hack your system. Okay, CS50 library. This is basically get int, get string, and all those functions we provided for you. So we have char star string, and that's the abstraction that we blew away at some point during the semester. Remember that a string is just an array of characters. So here we see an abridged version of getString. You should look back at it to remember how it's actually implemented. Key details are, notice we get in a single character at a time from standard in, which is just like us typing at the keyboard. So a single character at a time. And if we get too many characters, so if n plus 1 greater than capacity, then we need to increase the capacity of our buffer. So here we're doubling the size of our buffer. And that keeps going, or we insert the character into our buffer until we receive a new line or end of file or whatever, in which case we're done with the string. And then the real getString like shrinks the memory. Like if we allocated too much memory, it'll go back and shrink a bit. So we don't show that, but the main idea is it has to read in a single character at a time. It can't just read in a whole thing at once because our buffer is only of a certain size. So if the string that it tries to insert into the buffer is too big, then it would overflow. So here we prevent that by only reading in a single character at a time and growing whenever we need to. Okay, so get int and the other CS50 library functions tend to use getString in their implementations. So I highlighted the important things here. It calls getString to get a string. If getString failed to return memory, remember that getString mallocs something. So whenever you call getString, you should inevitably free that string that you got. So here, if it failed to malloc something, we return int max as just a flag that, hey, we weren't actually able to get an integer. You should ignore whatever I returned to you, or you should not treat this as a valid input. So then finally, assuming that did succeed, we use scanf with that special flag, which means first match an integer, then match any characters after that integer. So notice we want it to equal 1. So scanf returns how many matches it was successfully made. So it will return 1 if it successfully matched an integer. It will return 0 if it did not match an integer. And it will return 2 if it matched an integer followed by some character. So notice we retry if we matched anything but 1. So if we entered 123C, then, or 123X, then 123 would get stored in the integer, X would get stored at the character, scanf would return 2, and we would retry because we only want an integer. Quickly blowing through HTML, HTTP, CSS. Hypertext markup language, it's the structure and semantics of the web. Here is the example from lecture where we have HTML tags, we have head tag, body tags, we have examples of empty tags where we don't actually have like a start and close tag, we just have like link and image. There is no closing image tag, there's just a single tag that accomplishes everything the tag needs to do. The link is an example we'll see of how you link to CSS. The script is an example of how you link to an external JavaScript. It's pretty straightforward, and remember, HTML is not a programming language. So here, remember how you would define a form, or at least what this would do. So such a form has an action and a method. The method, you will only ever see get and post. So get is the version where the thing gets put in the URL. Post is where it is not put in the URL. Instead, any data from the form is inserted more hidden in the HTTP request. So here, action defines where the HTTP request goes. Where it's going is google.com/search. So method, remember the differences between get and post, and just say as an example, if you want to bookmark something. So you will never be able to bookmark a post URL because the data is not included in the URL. So HTTP is Hypertext Transfer Protocol. So the Hypertext Transfer Protocol, you would expect it to transfer hypertext markup language